I went out to the lake more than 150 days, and each day I brought back, somewhere between, 50 and probably 75 pounds of soil. Brought it back to the lab. I had a trailer behind my bicycle. So you start off at the early part of the day when you have lots of energy and your trailer's nice and light. And then by the end of the day, it's getting pretty heavy and you're getting tired. And it was very physically challenging. I averaged about 20 miles of movement on the bicycle each day. And I ended up bicycling more than 2,300 miles over that 2-year period to visit all parts of the lake bed.
I mean, I don't know many people that would do that would bike 2,300 miles for anything.
I'm more stubborn. If I had known how hard it was before I started, I'm not sure I would have done it. But once I got started, I couldn't stop. So that's more stubbornness than anything.
Did you know that the receding waters of the Great Salt Lake are exposing the lakebed and revealing toxic dust? Hello, listeners, and welcome to H2O and Beyond. My name is Alex Hahn, and each week we dive into the science, systems, and stories behind the water we use every day. In today's episode, we're taking a trip back to the Great Salt Lake, which we previously covered in episode 12. If you guys want to check that out, it provides a little overview of the topics we're going to discuss today, but it won't be necessary to watch the whole episode. So to help us understand, how bad the problem really is over there in Utah, I'm joined by Dr. Kevin Perry, a professor of atmospheric science at the University of Utah. Welcome to the podcast, Dr. Perry. It's great to have you on the show.
Well, it's great to be here. I always love talking about Great Salt Lake.
Yeah, so, I think the question I want to ask you first is, can you introduce yourself? Tell us a little bit about who you are, what you do, and the place you work at.
Yeah, so Kevin Perry, I'm a professor of atmospheric sciences at the University of Utah. Most people in Utah just call me Dr. Dust, and I'm fine with that. And that's because my research has been focusing on for the last 10 years about dust from Great Salt Lake. But I broadly study all sorts of different things associated with air quality.
I see. How did you really get into studying atmospheric science? What sparked your interest?
Well, I actually grew up in Kansas, and I was absolutely fascinated by thunderstorms, lightning, and gust fronts, and that just hooked me into learning more about the weather. And then I originally wanted to be a TV weatherman and decided that that was going to be a rough job. So I kept looking for other options and finally found my calling, which is basically trying to better understand air quality and improve people's lives by improving air quality in different regions that I've lived in.
Yeah, you said you're really interested in the weather in Kansas. Have you ever considered, like, as a kid, being like a storm chaser or anything like that?
Actually, no. It's quite dangerous, and but it is fascinating. I'd much rather basically chase dust storms, I guess, is what I'm famous for. So
Yeah.
a
And,
different type of weather.
yeah, like, what's your relation to the Great Salt Lake? Why are you working so hard these days to, protect it and raise awareness around the issues surrounding it?
Yeah, so I'm not a native Utahn. I didn't even see Great Salt Lake until I was on a family vacation when I was like 11. Had no idea I would ever live in Salt Lake City, had no idea I would spend years trying to save the lake. But it really came about from the simple fact that I am an observer of the weather and of air quality. And I started noticing dust plumes coming off of the lake bed about actually back in 2009 and
Hmm.
2010. And with my background in dust, I knew that this was going to be a potentially major environmental hazard. And as I started studying the dust, I fell in love with the lake and decided that at some point, the only way to really solve the dust problem was to actually solve the lake problem. And they've been intermingled in my mind ever since.
I see. You mentioned, like, you when you were 11, you took your first trip to the Great Salt Lake. Like, have you, like, many of our listeners, like, taken a swim in the lake or traveled to the many islands on the inside?
So I have swam in Great Salt Lake when I was 11. I haven't done it since.
Yeah.
I've thought about doing it, but just haven't gotten around to it. I've been on, I think, every single island that exists out on Great Salt Lake. There are no islands right now because they're all connected to the land at some point. So
Mhm.
it's kind of funny to call them islands, but I've been on all of them. I've basically been everywhere that there is to be on Great Salt Lake, at least the dry portions, because that's where my research has taken me.
I see, and I heard it's not the most pleasant experience swimming in the lake. I heard like from my last interview, you get like salt all over your ears and your hair, and it's a pain to get out.
Yeah, especially if you go to the northern part of the lake, which is a lot more salty.
Mhm.
So you're much more buoyant. So it's much more exciting to swim in. But the water's pink. And when you get out, everything just completely gets crusted in salt if you don't get washed off like immediately. And it's quite an interesting experience.
Well, yeah, listeners, if you want a more in-depth, explanation about the geography of the lake, how it came to be, you can check out episode 12 where I did a deep dive with Mr. Micah Safestein, who I think currently is the Great Salt Lake Water Coordinator over there. But Dr. Perry, would you mind giving us and the listeners a little overview of what the Great Salt Lake is and what makes it so unique?
Yeah, so it's the largest saltwater lake in the Western Hemisphere. And it's arguably the most important oasis for birds in the Western US. Every year, we have more than 13 million birds that come and visit Great Salt Lake as they're flying north and south on their migratory path. Why do they stop here? Because it's a food source. The birds feed on brine shrimp, which live in the water, and brine flies, which live along the shore. And they come here and they gorge themselves. And it's also a economic powerhouse for Utah. We actually extract salt and metals from the lake itself, and that brings in more than $1 billion to the local economy. It's been super popular in the past with boaters and recreationalists. Uh, when I first moved to Utah 25 years ago, you go out to Great Salt Lake and you would just see, 50 or 100 sailboats
Yeah.
out there on a given day. And it's so sad to see that most of the boats have been taken off the lake because the lake has been shrinking. It's been shrinking significantly over the last 35 years and reached its all time low in November of 2022, just 3 years ago. And as the lake has continued to shrink, it's set off a host of environmental and economic problems. The first of which was the dust, and then the recreation, the loss of the boating, and then the loss of the ability for the companies to extract minerals from the lake itself. And in 2022, we were right on the edge of ecological collapse. It was very, very close. So it's a lake that's in peril, but it's super important for the economy, for the ecology, and for our health.
Yeah, and can you give us a brief overview of why the lake is shrinking right now?
Sure. So I'm part of the Great Salt Lake Strike Team, which is a group of scientists at the University of Utah and Utah State University. And we partner with researchers at the state of Utah. And one of the things that we were tasked to do by the legislature here in Utah was to come up with that answer of why the lake is shrinking. And there are basically three options. It's either due to climate change, it's due to drought, or it's due to excessive water diversion for other purposes. And those are the three contributing factors. And the Great Salt Lake Strike Team determined that the climate change was only responsible for about 10% of the water loss over the last 35 years. And that's because as the planet warms up, the water warms up and it evaporates a little bit faster. The Western United States is in the middle of an ongoing mega drought. It's been going on for 25 years. And that, even if people weren't living here in Utah, Great Salt Lake would be lower due to the ongoing drought. And the strike team determined that the drought was responsible for about 25% of the water loss over the last 35 years. And that leaves everything else, which is anywhere from 2/3 to 75%, somewhere in that range, is due to excessive water use by the people who live here in Utah. We divert the water for other purposes, primarily our cities, our
Mhm.
industry, and agriculture. And there was a study done at Utah State University a few years ago that basically said we use 30% more water than what is sustainable for the lake, which, since we get almost all of our water from the snowpack, which falls in the mountains, the Wasatch Mountains, which are adjacent to the lake, in a practical sense, what that means is that we have to have 130% of normal snowpack just for the lake not to shrink. Anything above 130% in the snowpack, and the lake will likely rise, and anything below 130%, and the lake will continue to shrink. And that's because we're using too much water.
I see. And that 130% sounds really high. Like you can't really rely on anomalies like that to feed the lake, right?
Absolutely not. Las Vegas, thrives on odds that are much lower than that, and they make tons of money. And in this case, the deck is stacked against the lake, and year after year, it's on the losing end of that equation, and has been losing water for 35 years.
I see. And you mentioned like most of the water that's no that should be going to lake is diverted for human use, but that also provides the chance for us people to actually cut back on our water. It means that we can actually do something about it, right?
Yeah. So one of the big picture items is that if this was a problem that was being caused by climate change, I would just throw up my hands and say, what can we do about it locally?
Yeah.
If this was a problem that was being caused by the drought, I'd throw up my hands again and say, okay, well, let's wait until the mega drought is over, and then the lake will return to normal. But this is being caused by our choices, which actually provide some optimism,
Yeah.
because if we get the people educated about the lake and they realize how important it is and they want to save it, then we can convince the legislators that this is something that the people really want to fix. And then we can all work together and change our behavior to use less water, and actually return that water to its rightful place, which is back in the lake.
I see. And I think this provides a really nice transition, into what you love doing the most, which is researching the dust at the lake. So, could you like walk us through what exactly happens when the lake shrinks regarding the dust?
Sure. So the lake is enormous. And as the water has receded, or I should say, the lake is also really shallow.
Mhm.
Small changes in the lake elevation have a big impact on surface area. So as the lake has shrank, it's dropped more than 10 feet just since I've lived in Utah over the last 24 years. And that's a lake that was only 30 feet deep to begin with. And so it's lost, a third of its depth, and it's exposed 800 square miles of lakebed to the atmosphere. That's lakebed that used to be underwater that's now exposed. And when you have strong winds that move across a dry lakebed, it can start moving sand particles bouncing along the surface. And
Mhm.
those sand particles can dislodge the smaller particles called silt and clay that then get lofted into the atmosphere and blow off as a plume downwind of the lake. And just to put 800 square miles into perspective, it's about the same surface area as the island of Maui in Hawaii, or 60% of the size of the state of Rhode Island. So it really is a massive area, and 2.5 million people live immediately downwind of the lake. So there's the concern that the dust coming off the lake could pose a health hazard if the concentrations are high enough, or if it's frequent enough.
Yeah, and I know that you personally like to go travel to the lake and do your research. What like research techniques are you like currently using to observe the dust right now?
Yeah, so I'm an atmospheric scientist, and you would think that I would set up equipment around the edge of the lake and wait
Yeah.
for a dust plume to come and hit my site, but I'm not that patient. So I spent 2 years of my life riding around on a fat tire bike, collecting soil samples all over that 800 square miles of the lake bed. I put down a GPS grid system every 500 meters and went out and collected soil samples, and looked at the vegetation and the surface crust, and mapped out the surface crust on the lake bed and mapped out the vegetation, and took soil samples back to the lab so I could figure out what the dust was made out of. And so I spend a lot of time on a bicycle out on Great Salt Lake. And now I have a wind tunnel that I can haul around behind my bicycle. It's called a pie swirl. And I can go back to the places that I identified as being dust hotspots, places where dust is actually being emitted from the surface, and try and understand why only 9% of the lake bed typically acts as a dust source. And so I've been looking at the role of soil moisture, the role of the surface crusts that can form that protect the surface from the wind, and been looking at the role of groundwater, all of which seem to be pretty important in identifying which parts of the lake are actually dust sources.
I see. And why do some areas of the lake have this crust, and why do other places not have this crust?
So every winter, the lake bed gets wet. And most of the places will actually reform a crust as it starts to dry out. The exception are the places that are really sandy. And so the sandiest places on the lake bed never form a crust.
Mhm.
And sand moves around on the lake bed, but it doesn't get lofted. So it's not really an atmospheric, dust problem, but it contributes to dust because it can knock dust particles loose as the sand moves around. But what I've determined is that there are places on the lake bed where groundwater is fairly close to the surface, and it's constantly wicking up to the surface through what we call capillary action, and it keeps the surface wet or moist. And there are other places where that transport of groundwater is really slow, and those areas can dry out. And when they dry out, that crust becomes fragile. And it doesn't take much. People walking across it, people biking across it, people taking motorized vehicles across it, or even sometimes sand can break down that crust. And so, what I've learned by going out to the lake bed year after year is that the dust hotspots tend to show up in the same places year after year.
I see. And from what I'm hearing, you don't want this crust. You want the surface to stay moist, right? Is that what I'm hearing?
Well, you can do it either way.
Mhm.
You can suppress the dust by putting it underwater. You can suppress the dust by keeping the surface moist, or you can suppress the dust by keeping a surface crust intact on top, because the surface crust does a really good job of protecting the small particles from the wind.
So the problem comes when the crust becomes sort of fragile and weak, right?
Yes, exactly. And it starts to break down. The longer the lake bed is dry, the more frequent and the larger areas actually start to break down. But like I said, it pretty much resets every winter. And so you
Mhm.
start off, with a fully intact crust at the beginning of the year, and then depending upon how dry that year is, you can get more or less dust, hot spots forming throughout the year.
I see. And what did you actually find inside the dust that you collected?
So I was funded to actually look at the metals and to
Mhm.
see if there were any metals that might pose a hazard to humans that were breathing the dust. And so I collected those soil samples. I actually brought 3 tons of material back to the laboratory, and then I dried it and I sieved it, and then I resuspended it, and I pulled out the small particles that actually end up in your lungs.
Mhm.
So I wasn't looking at the composition of the big sand particles. I was looking at the composition of the PM10 particles, the ones that end up in your nose and your throat and your lungs. And I used a variety of analytical techniques to look at the or the elemental composition of 53 different elements. And then I compared the concentrations in the dust to EPA standards called regional screening levels. And a regional screening level just means that if the concentrations are below the RSL, then we probably don't have to worry about it being a health concern. And if the concentrations are greater than the regional screening level, then we label it a contaminant of potential concern. And we need to do more research to find out what the concentrations are in the surrounding communities. Because I'm measuring things out on the lake bed that may or may not be transported in high concentrations to the surrounding communities. And we need those types of measurements to get the dose that people are being exposed to. But what I found was there are 13 contaminants of potential concern in the dust that could pose health hazards. What kind of health hazard? Most of these are cancer-causing agents. And I'll give you an example. The element that I'm most concerned about is arsenic. Every single measurement that I took of arsenic out on the lakebed was more than a factor of 10 higher than the EPA regional screening levels for not only residents, but for industrial workers. And so that's a pretty scary concentration of arsenic in the soil. But like I said, there were 12 other elements of potential concern as well, which is why we need to have a high quality dust monitoring network around the lake in order to determine whether or not this potentially hazardous dust is causing an actual health hazard.
And you mentioned that there are PM10 particles and then there's sand. How come the sand doesn't get in our lungs when we breathe it in?
It just doesn't make it off the lake. So
Hmm.
if you go to the beach and you grab a handful of sand and you throw it up in the air, what's going to happen?
Just
It's going to
fall
come
right back.
right back
Yeah.
down, and you're going to get kicked off the beach. If you go to a farmer's field and you grab a handful of dirt and you throw it up in the air, the big clods will come right back down. But there'll be a cloud of dust that wafts away from that, and that's those small particles that we actually are concerned about.
I see. And yeah, I think I'm going to ask something that a lot of our listeners are curious about. How did you manage to move, like, you mentioned, what, 3 tons of dust?
I went out to the lake more than 150 days, and each day I brought back, somewhere between, 50 and probably 75 pounds of soil. Brought it back to the lab. I had a trailer behind my bicycle. So you start off at the early part of the day when you have lots of energy and your trailer's nice and light. And then by the end of the day, it's getting pretty heavy and you're getting tired. And it was very physically challenging. I averaged about 20 miles of movement on the bicycle each day. And I ended up bicycling more than 2,300 miles over that 2-year period to visit all parts of the lakebed.
I mean, I don't know many people that would do that would bike 2,300 miles for anything. You're like, I can see you're very dedicated in the work that you do.
I'm more stubborn. If I had known how hard it was before I started, I'm not sure I would have done it. But once I got started, I couldn't stop. So that's more stubbornness than anything.
And you mentioned that you found arsenic, like high levels of arsenic in the dust. Should we be panicking right now? How serious is this really?
So the unfortunate answer is I really don't know the answer.
Hmm.
Um, so I know that I don't want to breathe dust frequently because I'm concerned about exposure. But I don't know the answer of how frequent these dust events are and which communities are most impacted and what the highest concentrations are. Why don't I know that? Because the state of Utah doesn't have a dust monitoring network to answer those questions. And so I spent the last 3 years lobbying behind the scenes with the various people, including legislators and people that work in the government, trying to instill in them the importance of a dust monitoring network. And I'm really happy to report that the state of Utah has now agreed to build a robust dust monitoring network. It's fully funded. And they're in the process right now of installing the equipment around the lake and upwind of the lake. And I've been told that network should be fully functional by the end of next summer.
Wow.
So within a few years, we're going to know the answer of whether or not the dust poses an actual health hazard or not.
Do you think it'll get done like in time for us? Like a few years isn't too late in the future to get the answer to that question?
No, no. I mean, I would love to have had the answer 5 years ago. I mean, obviously, but we will know the answer in a few years. And in the meantime, this dust network is also going to, for the very first time, allow the Division of Air Quality to actually alert the public
Hmm.
about an ongoing dust event. So based upon their observations, they can actually send out alerts to the communities that are being impacted by the dust so that people can protect themselves. And you asked, am I super concerned about the dust? In part, the answer is no, because it's fairly easy to protect yourself from the dust. How do you protect yourself from the dust? Well, the first thing is you have to know it's there, and that's where that dust alert system is going to happen. And then you can put on one of those N95 masks that we all wore during COVID. They are very good at removing dust from the air that you breathe. They're not so good at wildfire smoke. The wildfire smoke is small particles, and about 50% of those particles actually make it through those masks. But they do a really good job on the dust. If you alternatively, you can spend your time indoors. Most houses, protect people from the outdoor pollution, especially dust that has trouble getting into the homes. But you have to know about it. And the other thing is that unfortunately our wildfire smoke plumes, they can last for weeks and just give us poor air quality for long periods of time. The dust events only last a few hours. When we have winds from the south, they can generally produce dust for anywhere from kind of 12 to 18 hours. And when the winds reverse from the north, the dust events typically only last 3 or 4 hours. So it's not something that you're facing exposure to for weeks on end. It's very short duration, and if you know about it, you can protect yourself from it.
And are these like big storms that are like visible? Is this like a giant cloud coming at me or?
Sometimes yes, sometimes no. There are three different kinds of events that happen with the lake. One is a dry dust storm. So that's exactly what you're talking about there, with a wall of dust moving off the lake. My observations is that we typically have somewhere between 3 to 5 dust storms that move into Salt Lake County each year. Some years more, some years less. That's the dry one. Here in Utah, sometimes these cold fronts are associated with rain and precipitation. And when that happens, it just rains mud here in Utah. Every single rain droplet that falls out of the sky collects dust particles on the way down, and it literally just rains mud. It's very good at removing the dust from the air, but it brings it down to the ground and covers everything. And then we have dust events, which are not as severe as dust storms, but are probably a lot more frequent because they don't require as strong a winds. And we don't really have a good idea of how frequent these dust events are. My best guess is probably somewhere between 20 and 40 days a year. But I'm really curious to see what the data shows because we don't have any systematic dust monitoring network right now, but we will, hopefully by next summer.
And when you publish the research from your findings, who do you usually like communicate this information to? Do you send it to the government or?
Yeah, so most of my research is funded by the state of Utah. And so all of the reports that I do go to the state of Utah and then are publicly released on their website. I also publish papers in journals. I do presentations at conferences to spread the word. And I do a whole bunch of interviews to help educate the public about the issues associated dust and what we've been finding out there.
And what efforts are currently being made to save the lake?
So if you'd talked to me back in 2019 when I finished my survey of the lake, I was really pessimistic about the future of the lake. I went out and talked to people, and most of the people I talked to didn't know that the lake was shrinking, didn't know dust was coming off the lake, and didn't understand that how close we were to having the entire ecosystem die. And so myself and some other scientists decided that we needed to go on an educational outreach campaign. And we did every media interview we could do, talking to all sorts of groups, schools and libraries and parent teacher organizations and medical associations and everything that we could do, anybody who would listen to us. And now when I go out and talk to people, it's the other way around. 80% of the people know that the lake is shrinking. They're aware of the dust issues, and more importantly, they want to save the lake. I'm not sure where the other 20% of the people have been living under what rock, but the legislators have started to listen. There have been some key people at the legislature that have taken this seriously, and they've made public proclamations, including by the Speaker of the House and even the governor, that we need to do what it takes to save Great Salt Lake. And the first thing that they had to do is they had to it's not very exciting, but they had to change the law. There were a lot of legal barriers that were preventing water from being dedicated to the lake. And so back in 2020, they had the most sweeping changes to water law that have ever happened here in Utah to try and remove those barriers so that we could start to implement our ideas on how to deliver water back to the lake. And so that's where it started. But it takes money, and it takes investment, and it takes education. And so the legislature has been working with the Great Salt Lake Strike Team to evaluate their ideas on things that they could try and do to help save the lake. I'll give you an example. So we know that most of the water in northern Utah is actually used by agriculture. So cities use 10%, industry probably uses 10 to 15%, and agriculture uses most of the rest. So you could literally turn off the water to every home and every business in northern Utah, and you wouldn't even save 30%, and the lake would still shrink. You cannot solve this problem without working with agriculture. And so the legislature has tried to come up with some ideas on how they can work with farmers to try and reduce their water usage. And one of the methods that they've decided to invest in is called agricultural water infrastructure optimization. It's a
long
name, but what it's really trying to do is to provide money to farmers so that they can deliver water more efficiently to their crops. You can imagine a sprinkler just kind of spraying water out into the air. A lot of that is just lost to the air. And instead, if you use drip irrigation or bubblers that flood the root zone, you can minimize the amount of water that's lost to the atmosphere. And so the legislatures put up more than $250 million for these improvements, but they require a one-to-one match from the farmers. So the farmers also had to put up $250 million of their own money to participate in the program. And they had more farmers participating than there was money available for the project.
That's great news.
And so the Great Salt Lake Strike Team basically said that if the legislature continues to invest in this over the next 5 years, they can actually reduce the water usage by agriculture by 15%. And that's without the farmers changing the number of crops that they grow or changing the acreage that they actually use. That's low-hanging fruit from our perspective. But once you've completed that program, you still haven't saved enough water. So you need cities to reduce their water usage for outdoor landscaping. In Salt Lake City, for example, all the water that you use indoors, 95% of that ends up in the lake. When you use water outdoors on your trees and your grass and your flowers, more than half of that is permanently lost. And so we're trying to reduce the amount of water that people are using outdoors because that's water that's lost to Great Salt Lake. And the cities are using about 5% of all of our water for outdoor landscaping. And then we have to be careful about what types of industries we invite into Utah. Right now, there's a big push to bring in data centers, but they require a lot of water. And so we have to be really careful about that. But on the good side is, if you look at the amount of water that's being used per person in Utah over the last 20 years, it's gone down significantly. So we are trying to use less water per person at the cities, but the problem is that Utah is very fast growing. So even though we're using less water per person, the number of people has gone up. So the water usage of the cities has stayed just about the same. It hasn't really reduced any. Um, but we need to continue to aggressively conserve water if we're going to, solve this problem.
So what I'm hearing is, things aren't actually looking too bad right now in terms of saving the lake if people continue to, save water and the legislature does stuff, cooperates with the farmers, makes some deals with them, right?
Unfortunately, we've got a long way to go.
Hmm.
So we're still in a mega drought. It's really hard to conserve water during a mega drought. And we're 25 years into this mega drought. If you look at the tree records, the tree ring records from this area, over the last 2,000 years, the average mega drought lasts about 35 years. The longest one was 79 years. So it's really hard to conserve when you don't have much water to begin with, which is why it's super important that we conserve water the most aggressively on the years where we actually have a big snowpack, because that's where you're going to be able to bypass all of our diversions and get that water to the lake. But there are lots and lots of things that we need to do collectively. And the lake didn't shrink up or didn't, decline this fast it took 25 to 35 years for it to get here. And even if we can conserve more than 30% of the water, it's going to take, 20 years or more
Hmm.
to restore the lake back to healthy levels. It's not a quick fix solution, but there's a very important sense of urgency that I think we need to instill on the legislators, that this is not a problem that we can ignore, that if we do, that the lake could actually die. There was an article that came out from Brigham Young University about 2 years ago that got a lot of press, and it said the lake will be gone in 5 years if we don't do anything. But the lake is never going to be gone. It's a terminal basin lake. All the water drains into that basin. But the question is, will the lake still be alive or will it be dead? And that's a very valid question. The lake very well could be dead in 5 years if we don't aggressively put water back in the lake.
And once it's dead, it's almost impossible to bring it back to life, right?
Unfortunately, or I should say, fortunately, I've learned that there are places on the lake bed where there is upwelling of groundwater, of fresh water.
Hmm.
And so, even if the salinity of the lake bed got super high to where the brine shrimp, started to die off and the brine flies started to die off, there would be pockets of brine shrimp and brine flies that could survive, so that if you put water back in the lake, that the system will rebound. And so I call that resilience. And we're lucky to have that type of resilience, and we certainly don't want to rely upon it. So if the lake does kind of start to go through one of these really tough, ecological time periods, there is hope
Hmm.
that we can save it. But I don't want to do that again. I don't want to come that close again, because it was really scary.
Yeah, and I think now I want to shift our focus to, something our listeners might, I think they might enjoy hearing, which is your belief on, communication and advocacy and the connection with science. And so I read an article about you on, I think it was Science Friday, and you mentioned that not everyone agrees that science and advocacy go hand in hand. And, me personally, I really disagree with that statement. I think our job as, scientists is not only to do the research, but communicate the findings and make sure that people actually know what we're doing and the implications of it. So, I believe that, the whole point of science is to improve our world and make it better. And this can't happen without the communication of ideas and advocating for policy. So I want to hear your thoughts on that.
Yeah, so I've done a personal journey over the last 20 years. If you'd talked to me 20 years ago, I would have said that the role of science is to find the answers and publish the results, and let everybody else kind of go from there. As I've gotten older, I've been reflective on that, and there are some things that are just so important, like Great Salt Lake, that scientists are uniquely aware of, and of looking at how things are going to proceed into the future. And I think we have an obligation to society to try and educate the public
Hmm.
about the potential hazards. But from my perspective, it's really important not to be alarmist, that you really need to temper your communication message so that you stay within what is scientifically defensible. And I think where some scientists get in trouble is they go beyond what the science actually leads them to. And that is where they start to lose credibility. And as a scientist, I think it's really important to maintain that credibility. So,
Hmm.
for example, you keep talking about toxic dust. I never use the word toxic
Hmm.
because toxic implies that people are being harmed and that we know what the dose is that people are being exposed to. And, as I alluded to, we don't know the answer on whether or not the dust is causing an actual health problem. I suspect that it probably is, but I need to wait until we have scientific evidence in order to sound the alarm. But what I do is I alert people to the potential hazards and try and get them to move in a direction to minimize those hazards while we are simultaneously trying to do the work that's necessary to find out whether or not people are actually in danger.
I see. So, you mentioned like maintaining the credibility of the science, which I believe in as well. So, I do think it's really important for, scientists not to first, like overstep their boundaries or, like don't like say stuff that, you can't support or back up with your data. Otherwise, things could just go all sorts of wrong.
Mm-hmm.
And, I think as a professor and teacher, what's something that your students do which makes you really happy or proud of them?
Ah, so for example, just this last year, I taught a year-long class on Great Salt Lake. And the first semester, these were honor students. The first semester, we were just learning about all of the issues associated with Great Salt Lake. And then for the second semester, the students had to come up with a project of something that they wanted to do with regards to Great Salt Lake. And what the students decided to do was to try and get the Great Salt Lake wetlands recognized by an international treaty called Ramsar that recognizes wetlands of international importance. And so what they did is they worked on the application for the Ramsar designation for the Great Salt Lake wetlands. And the application is ready to go as soon as the government decides that they put a pause on all participation in the treaties. And as soon as the Ramsar Treaty is evaluated to determine if the U.S. still wants to participate in it, then we have that application that's ready to go. And so that was a clear example where the students saw an opportunity to permanently recognize and protect a part of the lake that I've spent very little time and effort at, but I was happy to learn more about it. But I'm super proud of the application that the students put together for that.
And what's some advice you would give to some newer scientists or just scientists in general trying to get their work recognized and make some change in the world?
So I'm a huge fan of what I call applied research, which is trying to tackle questions that are relevant to society. So there's a lot to be said for basic research. Some of our key technological inventions and that sort of thing that we all benefit from is super important. But I'm most personally fulfilled by knowing that I've made a change that has improved the lives of people directly. And as an air quality scientist, the most obvious way to do that is to work to improve local air quality. And so my advice to students is basically find something that you're passionate about and focus in on that. And if you're passionate about it, it's not going to seem nearly so much like a job as it does like a calling. And so, I'm getting old enough, getting, close enough to where I'm starting to see retirement. But the idea of retiring isn't super exciting because I really love what I do.
Yeah, that's great news. And I'm really inspired by your story and how you're pushing to get the word about the Great Salt Lake out. And As we sort of wrap up this episode, are there any final words you'd like to say to our listeners?
Yeah. So in order to save the Great Salt Lake, we really have to push the legislators in order to give them a sense of urgency. So I've been working, behind the scenes to do that. I think the public has a lot of sway at electing leaders that are actually focused in on that sort of thing. And so, my journey from scientist to advocate has one more step in the process, and that's that I actually intend to run for the legislature in a couple of years in 2028 to try and participate directly in crafting policies that can then help save the lake and protect people. So I have no idea if I'll be successful, but certainly going to give it a go.
Have you considered joining I know I did an episode with like a think tank from Texas a couple of episodes ago. They use the research of their scientists, they gather data and they try to, advise these legislatures on how to make their policies. Have you ever thought of doing something like that?
We already are doing that through the Great Salt Lake Strike Team. And that's the thing that's kind of inspired me to think about pursuing this, is because now working directly with the legislators, it's not something I ever aspired to, but actually meeting them and learning how they operate and how they think has actually made me think that I can participate in that. But in the meantime, I'll just continue working through the Great Salt Lake Strike Team to help try and craft good policies that are good for the lake and good for Utah.
Well, Dr. Perry, I wish you great luck in your legislative run in a few years. And I think this was a great episode, and I really appreciate your insight on scientists' role in society and how to save the lake. And once again, thank you so much for joining me today on H2O and Beyond.
Absolutely, and thank you so much for shining a light on this super important topic.
Well, listeners, if you found this episode helpful, please share it with your coworkers and friends. If you want to be a guest on the podcast or have any episode suggestions, there'll be a Google form linked down in the description for you to fill out. If you want to learn more about the Great Salt Lake or are interested in, Dr. Perry's research, I'll put some, links to that in the description. And as always, check out our link tree for information on where H2O Beyond is going. And, I actually just released a special episode on December 2nd where I was actually being interviewed by Baxter Woodman, a civil and environmental engineering firm, on my stance on, the water industry and what needs to be done. So, yeah, if you're interested, feel free to check that one out. I'm Alex. Thank you for listening to H2O and Beyond. Stay curious and stay hydrated.